Hey guys, welcome to my living room. I miss you all so much. Zeus is mad because I just put his bark collar on him because he wouldn't let me record these videos without chiming in as well, so he's moping on the floor over there. But he is very excited about these molecule models also because I'm going to drop the gumdrop, which he got to eat, so he was very happy about that. So you should have all of your gumdrops sorted. You should have your colors decided, like I'm going to be using orange for hydrogen, I'm going to be using purple for nitrogen, so you should have that already decided. And now we're going to start making our models. Quick random side note, I remember as a kid hearing a story about a girl who was taken hostage and they filmed a ransom video of her. And they sent this ransom video out to whoever was supposed to pay the ransom. And as they were watching her ransom video, they're like, man, she's blinking so weird. Like, what is wrong with her eyes? And then they realized that she was blinking in Morse code and she was sending them the location where she was so they could come rescue her, which they did. Isn't that crazy? Mind blown. But ever since I've heard that story, anytime I see a video of myself, I'm so self-conscious of how I'm blinking. Like, could I be sending a message and not even know it? So that was my side note for I miss you all. That was what my blinks were saying. So in your Google Doc, the next sheet that you should see is this one. And these are our Lewis structures that we're going to be using for making our models of our molecules. And we already talked about how water, carbon dioxide, fructose, and caffeine are the 4 key ingredients in a can of soda. So can we illustrate that using our gumdrops or our marshmallows and our toothpicks? So we're going to start simple and then work our way up. And I'm going to show you what I did that you might be able to do in your science notebooks, which made the model making process much easier. So we're going to start with water. So let me flip up to this one. Look at there. So what I did was I took my colored pencils, you could use your crayons that I sent you, and everything's backwards, and we're doing H2O. So my hydrogens, I'm going to be using my orange gumdrops. My oxygen, I'm going to be using red. So I just quick made for myself here, like, how do they figure out this Lewis dot structure? Like, that's what I'm trying to determine here. How does H2O get to look like this? That's what my brain said. How did they get that? So we're going to just figure that out for a second. So hydrogen only has 1 electron. We know that there's 2 hydrogens in water. Oxygen, their outer electron ring, wrong way, backwards, has only 6 electrons in it. You can check that on your periodic table because of its column. And it wants to get to the octet rule. Happy rings, full rings. And so it is going to look to get 8 electrons. And hydrogen each bring theirs in. Remember when we took, I can't figure out this backwards thing, but remember when we took our beads and we brought them together and boom, wrong hand, this one. Wow, my brain is getting such a workout. So they bond in a covalent bond to have a full 8. Hydrogen gets its 2, oxygen gets its 8. They're all stable. So the Lewis dot structure, is that what it's? Yeah. The Lewis structure is simplifying this so that you don't have to draw it every single time. And so what they've done here is the line here from the hydrogen to the oxygen represents 2 valence electrons. And then the extra dots there and there are the extra ones chilling around oxygen, giving it its perfect 8. But in this bond, we know that it has 8. It is happy. We don't have to leave these dots here. I can simplify it and just show it like this. The bond means it is full, it is stable, it has its full outer ring. So what I did then was, let me tilt the camera down and see if I can show this to you. It's going to be backwards. Let me flip this around. There we go. So what I did then was I've got my orange hydrogen. So then I took, where are they? So then I took my orange gumdrops, ka-ching, and then I took my red gumdrop, and then I knew that I needed to take my toothpick and bond them. And just like that, I have a representation of H2O, a water molecule. So now you can pause the video and make one of your own, or you can continue watching with me and do these on your own afterwards. We're now going to move on though to carbon dioxide. So you can see that I was struggling making circles. Let's not talk about how many times I tried this and then was finally just like, I just wasn't made to make perfect circles with a Sharpie. So just work with me here. So I chose green to be my carbon molecules. Red again is my oxygen. I know that I have 2 oxygens. Oxygen, like in our last example, has 6 valence electrons. Carbon has 4. So 6 and 4, and then we start thinking to ourselves, they each want 8. They each want 8. How would they do this? So then we look down to our dots here. They do a double bond. So oxygen shares 2 of carbons for its 8. Carbon shares 2 of oxygens for its 8. Look at that! They each have 8 by doing a double bond. They each share 2 valence electrons. So the double bond is my 2 lines here. 4 valence electrons total. So if you were to compare that to our lab sheet, 2 lines are double bond, 2 valence electrons. So now, let's make this. So, I'm going to take my green, put it there, and my reds, and line them up, and then I'm going to start breaking my toothpicks. Or, like on all the cooking shows, and there it was! Shazam! So there's our carbon dioxide double bond molecule model. But wait, it's gonna get trickier. So, next up is fructose and caffeine. Now, hopefully we're seeing how the electrons translated to this, which translated to this. Because both fructose and caffeine are what we would call complex molecules. The ones we just did, simple, right? That wasn't very complex. That wasn't very complex. Those are very simple. What we're about to make is very complex. So, fructose, I didn't draw out all of my electron rings. By this time, I know what carbon looks like, I know what oxygen looks like, and I know what hydrogen looks like. I know what they have to offer as electrons. So when they start bonding, look at what happens. Carbon, 1, 2, 3, 4, 5, 6 carbons. They all pair up with some hydrogens, and then our OH picks some random sides. Now, my brain went, why does the one hydrogen chill over here with the HO here? Well, all these other ones chill with hydrogen here and the OH here. And I don't know the answer to that question yet. I do know that it has something to do with how a simple let me move this over here, gives you a whole new molecule. So we talk about like fructose, glucose, sucrose, those are all the sugars. And all of those are formed from just a simple rearrange. Okay? So a simple rearrange. So for fructose here, what you can do is in your science notebook, you can take the Lewis structure from down here and make it big, because these complex ones, they're tricky. okay, to make our models of it. So write it big like I did on my sheet here. And then I took my colors again. I took my colors and I assigned my colors to them so that then I can start laying out where everything goes. So I don't have enough gumdrops because I've got some already stuck together here in pieces, but I'm just going to kind of show you how this would go, right? So we would put oranges and oranges and orange and a red and a green, and we would just keep going. I could go along and say my reds are going to go here and my reds are going to go here. And then once you've got it all laid out like this, it's so much easier to then be like, okay, one popsicle stick bonds, one toothpick bonds all of these. This one's a double bond. So that one I'm going to snap in half and do a double bond with a green. And then you just go along and you're going to get a really cool model. And you're going to take a picture of the model to send to me. Okay, so this one I'm not going to show you in completion because I'm hoping that this model making process is making a little more sense to you. I am including pictures for you to see my models, but I really want you to make them for yourself, and I want to see evidence of them for you to get full credit. So that would be our fructose, and then our final one is caffeine. So we know that caffeine is complex just based on the fact that it's the energy one, right? It's the energy one. And so when our bodies are processing caffeine versus little water, what's going to be happening? So let me see if I can hold this up. There's caffeine, right? Complex for sure. So again, I took the Lewis diagram right here, Lewis structure, and I made it big, and I took my colors that I had assigned to it, and I used my colors, and then I simply laid out my gumdrops in its spot, and then I went about assembling it. So you're going to make me caffeine, and you're going to take a picture, and you're going to send it to me for your full credit. And I can't wait to see your models. So, happy model making. I want to see each of your models. I want to see your water. I want to see your carbon dioxide. I want to see your fructose. I want to see your caffeine. 4 models, and then we wrap up this lab. Happy model making.